lot of the students I've seen have used integration by parts. It looks like an integration by parts question. We've got this x times by something we can integrate. So your natural instinct, I think, would be to integrate this by parts. It's not, I don't think it's how the examiners expected you to answer the question, but it's a completely legitimate way to answer the question. It's probably the method I would have chosen as well. So I'm going to start off by showing you integration by parts, but I will show you another method that you might be interested in too. This is the thing we're going to want to differentiate. So I'm going to call that my v, and I'm going to call this u dash. And if you remember, the formula for integration is that if we've got something in the form u dash v, that's equal to uv minus the integral of uv dash. So u dash is what we're integrating, so that's x plus 2 to the power of a half. And v is the thing we're differentiating, so that's 2x. So v dash is going to just be 2. U is the integral of this, so that's when you add 1 onto the power, divide by the new power, so divide by 3 over 2 is the same as timesing by 2/3, and divide by the coefficient of x as well, but in this case that's just a 1. Once we've got all this written down, we can just shove it in the formula. So the integral is going to be uv, so that's this times 2x, so 4x, x plus 2 to the 3 over 2 all over 3, minus the integral of uv dash, so that's these two things times together, so that's 4x plus 2 to the 3 over 2 over 3. This we can integrate, which means we can finish the question. So 4x, I'm not going to do anything with this yet, 4x over 3 minus, add 1 to the power, we've still got the 4 over 3, you could even take the 4 over 3 out here, but we'll leave it there for now. Add 1 to the power, that's 5 over 2 now, divide by 5 over 2, that's the same as timesing by 2 over 5, that's a 2, and divide by the coefficient of x as well, but that's just a 1, so I don't need to write it down. Let's just tidy this up. We've got 4x, x plus 2 to the 3 over 2 over 3, minus 8 over 15 times x plus 2 to the 5 over 2. So we've finished all the integration steps now. Now it's just a case of substituting 2 in and subtracting what you get when we substitute 0 in. So we're substituting in 2. We're going to have 8 over 3 times 4, 2 add 2, so 4 to the power of 3 over 2. 4 to the power of 3 over 2 is going to be the square root of 4 cubed, so that's 2 cubed, which is 8. In this one, we're going to have 4 again to the power of 5 over 2, so that's again the square root of 4, which is 2, but this time to the power of 5, which is going to be 32. Then we're going to substitute 0 in. If we substitute 0 in here, we've got a 0 being times by something, so that bit's going to be 0. Be careful though, this bit's not going to be 0. This bit is going to be 8 times 2 to the power of 5 over 2 over 15. I'll deal with that in a minute. This is going to be 64 over 3 minus 832s are 256 over 15 minus, so plus 8 times, this will be the square root of 2 to the power of 5, or the square root of 32, the square root of 2 to the power of 5. (64/3) minus 256 over 15 is 64/15. And then we've got this root 32. How do they want the answer? Oh, they're telling us what to write it as. We've got this root 2 here. That's easy to sort out. Root 32 is, you can check it on your calculator, 4 root 2. So we've got 8 times 4 root 2, which is 32, root 2, over 15. And then they've taken out 32 over 15. There's 2 of them here, so that takes out a 2 plus just root 2. And that's your final answer. The other way you could have done this, you could have actually done it as an integration by substitution question. Okay, so I'm going to go through that as well. To do it as a substitution question, the reason we can't integrate it as at the moment is because we can't multiply this x into these brackets and just have terms at a time that we can integrate. We would be able to if we just had a root x times something linear. So if it had been the other way around, we'd be able to write that as x to the power of half and then multiply out the brackets. So if it had been switched around the other way, we would have been absolutely fine. We can switch it round the other way by introducing a substitution. And the substitution, there's a couple of substitutions you can choose. The easiest, most straightforward one that you're probably going to like the best is just letting u equal x plus 2. If you let u equal x plus 2, du will equal dx, because if you differentiate x plus 2 with respect to x, you're just going to get 1. So you'd get du by dx. If you're used to doing it this way, you'd get du by dx is equal to 1. Bring that up, you get du equals dx. So that's just a straight swap. We can just straight away swap dx for du. The other thing we can do is swap this x here for u minus 2. X will be equal to u minus 2 if that's the substitution we're using. So if we do that over here now, we're going to have 2 lots of u minus 2 times root u du, because du can be swapped for dx. The limits are going to change really easily. These are the x limits, but u is just x plus 2. So when x is equal to 2, u will be equal to 4, and when x is equal to 0, u will be equal to 2. So these are my u limits now. And then we can just get on with integrating. We can integrate this. It's going to be, as I said, we can write this as a power of a half. I can even put the 2 outside, get that out of the way. U take 2 times u to the half. And expand the brackets, we're going to get u times u to the half, which I'll sort out in a second, minus 2u to the half. U times u to the half, that's a power of 1, so if we add the powers, that's 3 over 2. And that's easy to integrate. That's just add 1 to the power, divide by the new power. Nice and straightforward. So if we do that, we're going to get u to the 5 over 2 divided by 5 over 2 or times by 2/5. And here we're going to get, oh, I've lost me 2, hang on. We're going to get add 1 to the power, which is 3 over 2, divide by 3 over 2, or times by 2/3. Limits are 4 and 2 now. So that's a 4, so we've got 2u to the 5 over 2 over 5 minus 4u to the 3 over 2 over 3, between 4 and 2. If we substitute 4 in, we're going to get 2 times 4 to the power of 5 over 2. That's going to be the square root of 4 to the power of 5. So that's 2 to the power of 5, which is 32. Substitute, 4 into here. We're going to have square root of 4 cubed, which is 8. So 4 times 8 over 3. And then when we substitute 2 in, we're going to have 2 times 2 to the power of 5 over 2 over 5 minus 4 times 2 to the power of 3 over 2 over 3. So here we've got 64 over 5 minus 32 over 32 over 3. This we've just worked out on the other example, we can write as root 32. And root 32 is, what did we say it was? Is 4 root 2. So I've got 8 root 2 there. 2 to the power of 3 over 2 is root 8. So we've got 4 times, and root 8 is 2 root 2. So we've got 8 root 2 over 3 there. We can work out 64 over 5 minus 32 over 3. That's 32 over 15. And we can work out, I'll just do that on the calculator, 8 root 2 over 5 minus 8 root 2 over 3. That's minus, so this is going to become a plus 16 root 2 over 15. And just a couple of steps left to go. We're going to bring this 2 back in and swap it for a 32 over 15. So that's going to be 64 over 15 plus 32 root 2 over 15. And if we take out the 32 over 15, we'll have a 2 here and just a root 2 there. And that's the same answer that we got earlier, and it's the answer that we were looking for as well.